Welcome everybody to a contemporary Wi-Fi toolkit for Apple system administrators. I'm glad to have everybody here. Hello to everybody in 206. I just learned that we're streaming to the other end of the building. Please, I guess I would suggest that we throw questions into the Dean's Hall 2 room for me to review later. If you have questions at that end of the building, and we'll find a time to take questions here. My name is Chris Dawe. I am an Apple technologist based out of Seattle, Washington. Currently living with my partner Emily and 2 guinea pigs. I am the co-founder of the Mac Admins Foundation, the co-founder of Apple Admins of Seattle and the Great Northwest. How many Expanse fans do we have here? So you'll know the term on the float. I am on the float. I'm currently on a career break. So I have a lot of time. You can find me at CT Dawe in various Slack channels, including Cascadia, where we've assembled everybody from the Pacific Northwest, the Mac Admins Foundation, where I'm doing much of my current work, and then technical channels such as Wi-Fi and Network Nerdery. So we're here at least in part because what I thought it was a good idea was to do this year was to revisit the state of the Wi-Fi toolset market, because I realized in talking to Tom Bridge that it has been 10 years since we first did our Wi-Fi workshop, and a lot of things have changed. Things change a lot in time, and while it's true that tools have changed and improved, it's also true that over time my understanding shifts, deepens, improves, and changes as well. So I wanted to come back to some fundamentals and see where the market stands in terms of tool sets. At the same time, it's also true that tools are an aid for understanding for some things that never ever change. And one of the things that should be fun and maybe a little terrifying about this particular version of this talk is that some of the things that happened in the other end of the building yesterday got injected into my Slack channel, and that has given me the opportunity to do a couple of live tool demos that I wasn't planning on, so we're going to do what we can to appease the demo gods. Hopefully the keynote thing has handled that for us. What I'm going to do is I'm going to talk mostly on 3 main topics. I'm going to detail into those unplanned things. And then I'm going to touch on a 4th key topic that I think kind of ties a bow on all of this. I want to give you a snapshot of key Wi-Fi tools that are in the Apple ecosystem as of 2024, while also providing some insight into the importance of those tools and updating our understanding of some tools that may no longer be relevant to us but are often still considered very important. So to that end, I'm going to talk mainly about 4 topics. I'm going to talk briefly about some of the Apple tools in the Mac operating system. I'm going to talk about third-party software. I'm going to talk about hardware tools that often integrate with that third-party software. And then I'm going to talk about knowledge and experience. Questions so far? Or I'll dive right in. Okay, so at its most basic, Apple doesn't provide a ton of tooling for understanding or working with Wi-Fi and macOS, but there are a few basics that can get you started. And if you haven't been to one of my talks before, some of these things may be new. A lot of these things may be a refresher if you have been to my talks before. You can gather some information about the state of your Mac's Wi-Fi with these tools. First and foremost is going to be the macOS Wi-Fi menu. And the thing that's special about the macOS Wi-Fi menu is really twofold. One is you get a lot more information about the state of your existing connection if you option click the Wi-Fi menu. You get a lot of detailed technical information about the connection that you have, the quality of that connection, what equipment you're connected to, and then you also get access to a menu item that lets you open Apple's Wi-Fi diagnostic tools. These provide a set of basic tools, and I'm going to characterize these as pretty basic, to gather information about the networks in your vicinity and your network connections. You can get a little bit of performance information that's fairly simple. You can scan your network environment, you can initiate a packet capture, and you can gather Apple's logging. By the standards of what we're going to look at, These are pretty basic tools and they don't do a whole lot, but if you have a fleet of machines and you're attempting to troubleshoot, you have an opportunity to tell your end users or your help desk staff that, look, Apple does at least have some diagnostic stuff built in that we can get a basic view of. You don't have to go out and buy third-party software for every machine on the network, even if it might be helpful. Apple also provides a command line version of the diagnostic tools, WDUtil. This is one of my favorite tools because it seems like every time I forget about it for 2 weeks, I can't remember the name of the tool and I have to go look it up. It provides much the same functionality as the GUI-based version of the diagnostics, but it requires administrator privileges to access that information, so you have to use sudo. And we're going to see in a couple of places where that's going to be potentially a problem. There are a few other CLI-based tools worth at least knowing about. Network setup has a number of different functions to both configure networks and also read information out of networks. And one of the most important things you can use it for is just grab the SSID that your computer's connected to at a particular moment. And that's something that's commonly used for reporting systems, diagnostics, etc. A bunch of Wi-Fi information also shows up in System Profiler. But other than that, we don't have really a lot, and there have been some important changes over the course of macOS 14 as Apple has been continuing its move towards increasing user privacy. Apple now considers location-based information to be privileged data that requires the user to enable a setting in order for an application to access that data. That is, Wi-Fi information is now considered at least somewhat privacy protected. So the first time you launch any one of a number of applications on a Mac that will gather Wi-Fi data, you're going to be prompted for location access for those applications. This is something that's been going on for a while, but it's become more formalized. A few years ago, we would see applications fail to gather data, and we didn't understand why. And we eventually figured out that this was something that had to do with location privileges, TCC, location services, etc. Let's see. In addition, there's a long-standing tool buried in Apple's private frameworks. And you saw it on one of the previous slides. It's something that if you do searches for Wi-Fi command line Mac, you're going to find it a lot. Buried in the private frameworks in the system folder in macOS is a little utility called Airport. And Airport had some functionality to do scanning without administrator privileges and gather information without administrator privileges. And Apple has been saying for some time that this is a tool that they're going to deprecate and stop supporting. And when Apple dropped macOS 14.4 on us a couple of months ago, the ability to use that tool abruptly went away. This broke a lot in terms of people's shell scripting for gathering information about Wi-Fi from a larger fleet. A couple of the comments that I've seen in various places are, yes, you should file feedback about this if this is important to you. But what we've also seen is we've seen some suggestions that you just go ahead and use WDUtil. Some developers of third-party applications for monitoring have done things like implemented special sudoers configurations that they deploy so that their application has specific privileges to this one thing. In order to try to operate on the principle of least privilege. We've seen other applications try to move towards Swift-based compiled applications, but Apple is requiring that location access or those location privileges on pretty much all applications that are gathering this kind of information as of macOS 14. And so your users begin to have to provide those privileges, which increases friction in terms of deployment. So that's kind of the state of things as far as Apple's tools are concerned. Moving on to third-party software, I want to talk about a number of tools here. Turn off this Sorry, I didn't turn on DND before I started. I want to talk about a number of different categories of tooling that are available on the Mac platform. We're going to talk about network scanners. We're going to spend some time on that, and we're going to come and go on that because when we hit network hardware, we're going to see some of that too. We're going to talk about packet capture and analysis. We're going to talk about network mapping and survey software, network planning software, and a new category of software that, for lack of a better term, I'm thinking of performance testing and assessment software. So as far as network scanners are concerned, if you are doing Wi-Fi and you can afford one tool, Intuit Bits Wi-Fi Explorer Pro and its related tools are probably, in my opinion, as a consultant and a technologist, the best bang you're going to get for the buck. I think of it as the gold standard. It has steadily improved and the developer has steadily added features as other very common applications from 10 years ago have kind of come and gone in terms of network scannings. It really represents kind of the highest tier of achievement for this type of software. In the broadest description, Wi-Fi Explorer is a general wireless network scanner, but that isn't really adequate for what this thing can do. The tool reads, extracts, and displays a combination of what your Mac can determine and see about a wireless network environment. And it combines everything, combines that with everything that your detectable networks will say about themselves, which is a really important concept around network scanning. Features include active and passive network scanning. Passive scanning is important because you can disconnect from an existing network and you can listen for whatever traffic is flying by. And one of the benefits of that is that you will often pick up networks that are hidden or invisible, intended to be secured. We're able to import and export PCAP files from various capture applications. We've got some extremely powerful filtering. The ability to pick up all of the information that access points broadcast about themselves, because one of the things that's kind of inherent and implicit in Wi-Fi is the idea that the network in general would be telling you about itself all the time if only you've got the tools to listen. And then it has other integrations for hardware such as spectrum analyzers and a lot of internal filtering and profile settings so that you can change views over and over again and examine different types of data without losing your previous view. It's really just a handy piece of software. A couple of examples of the types of things that it can do. In the example shown on the screen, the network being scanned is configured to share channel utilization and load information, and the Wi-Fi Explorer Pro user can read this data straight out of the app and arrive at a quick visual assessment of whether a network or an individual access point are overloaded or not. The only downside of this is whether the network team will believe you. In another example, the app's visual spectrum display can show you all sorts of interesting things. In the example on screen, we can see overlapping access points in the 2.4 gigahertz spectrum on the left, that is channel 6 and channel 11, which is likely to lead to significant co-channel interference and degraded performance on the network. On the right, we can see overlapping channels as well as noting that the channels are 80 megahertz wide on the 5 gigahertz band. A performance-oriented design would narrow those channels to 20 megahertz or 40 megahertz in order to reduce that overlap and spread the access points out across the channels in order to reduce contention. Because the spectrum contention inherent in 4 access points with all their clients on the same channel is all but certain to result in drags on performance that render high TX rates that you might see as a benefit of 80 megahertz channels just really not a real thing. You'll see the computer claiming to have a high performance connection, but it won't actually be able to perform at a high level. Was anybody on the 200 side yesterday? when the network kind of crapped out, I'll have essentially this is what was going on yesterday, and I'll have some live captures of that from yesterday's events. There are a lot of other common problems that Wi-Fi Explorer Pro can help you identify. I can barely read my slide previews, so channel width mismatch, excessive spectrum use, so on and so forth. And so for me, this is the handiest kind of Swiss Army knife of a tool that you can have as a professional. And in a lot of ways, this tool gets you 80 to 85% in my estimation to what you need to really be a Wi-Fi engineer. There are a lot of other benefits to much higher end applications, but you're not always going to need these. And oftentimes, if you're attempting to diagnose a network, it's just as easy to flip open Wi-Fi Explorer Pro, kind of take a look around, see what the network is configured as, and do some assessment and analysis, because it just makes seeing these kinds of problems so easy. It has a companion application called Wi-Fi Signal, which displays a great deal of information about your Mac's active network connection and can be configured to display that information in your Mac's menu bar. In addition to that, Wi-Fi Signal will read annotations that you have in Wi-Fi Explorer Pro and display them, telling you things like what's the casual name of the access point that your computer is connected to. So if you've labeled your access points in terms of hallway 1, hallway 2, hallway 3, Wi-Fi Signal will display that information for you. And so you don't necessarily have to read BSSID MAC addresses. The other really cool thing about Wi-Fi Signal is that it logs a number of different types of client network events for your Mac, which are things that you don't often see indications or logging of. The thing that I'm most fond of is seeing roaming events happen. When your Mac switches from one access point to the next, Wi-Fi Signal will also display network performance changes and a variety of other events, and that can be extremely helpful for network tuning. Finally, there's a third component to what I think of as the Wi-Fi Explorer suite, and that's called AirTool. And that adds an always available function that enables custom packet captures directly out of your Mac's Wi-Fi, or directly out of your Mac's menu bar, using either the Mac's wireless network card or using a remote sensor. Which can be any one of a number of things. One of the things that the developer of Wi-Fi Explorer Pro is also fairly famous for in the Wi-Fi community is working on the WLAN Pi project, which is a little Raspberry Pi configured as a network testing device for Wi-Fi. And one of the things that has been provided in both of those applications, or that application and that device, I should say, is the ability to use that Raspberry Pi somewhere else as a remote sensor in order to perform detection. One of the places that I found this particularly useful early on in the development of Wi-Fi 6E and the 6 gigahertz spectrum is I had a MacBook Pro that did not have a card that supported Wi-Fi 6E, but I had a Raspberry Pi, or rather a WLAN Pi that did, and so I was able to do captures and testing on 6 gigahertz without having to upgrade my laptop. I mean, there weren't upgrades to be had at that point because Apple hadn't released that, so it was really a critical thing at that point. Now that I have a M3, it's a little less important, but it's still a worthwhile feature to consider. And AirTool can also take those captures and then hand those captures off to a couple of different cloud analysis services, or it can hand them off to our friend Wireshark, which is a free and very powerful packet capture and network analysis tool. These slides come from some other presentations that I've done. This is an example of a Wireshark capture that shows the association of a client Mac to a network and then a reassociation that happens when there's a roam. I don't really need to go necessarily through all of the details of this. I went through that in my roaming talk last year, but you can kind of see that Wireshark provides a very large amount of information about network sessions and network transactions. And one of the things that we say is that the packets don't lie. Another thing that we say is packets or it didn't happen. And so if you're troubleshooting a really nasty problem, grabbing packet captures of the live devices when they're having the problem and then analyzing can be a great way to move towards solving the problem. Wireshark also has some built-in analysis tools for graphical or statistical analysis. What you see on screen is a view of a capture of a set of wireless sessions from a particular network. And the two graphics on the screen are the amount of traffic, which is the higher set of numbers, and then the lower set of numbers is the number of retries on the network. And this is a really key piece of information in troubleshooting Wi-Fi in general, because every network packet in Wi-Fi has to be acknowledged by the recipient device, or the sending device assumes that the transmission failed and will retransmit it. And so in this particular case, what we have is a network environment that was congested enough, crowded enough, or suffering from enough interference that approximately 20% of the packets in the session were having to be resent. And that is the kind of place where you'll start to see network performance degradation. One of the challenges to Wireshark is that the language and the vocabulary for using it are really quite arcane. And effective use of the tool depends on understanding at least some of that arcana. There's some great online courses about how to use Wireshark. And in addition, a prominent Wi-Fi consultant in the Canadian market generated a PDF cheat sheet that you can download to tell you how to do the searching, which particular information elements you want to look for in order to construct a search for a particular type of Wi-Fi session. So that's Wireshark. Free, powerful, arcane, and indispensable. And then moving on to kind of a little bit more of a new product category, we have a product called InOversight. This is a product from a company in the United Kingdom and a consultant named Ben Toner, who wanted to look for a way to, and I have a hard time characterizing what we're doing here. We're assessing the performance of clients. We're reviewing traffic, we're recording what's going on a particular device, and we're drawing conclusions and sort of making assessments and recommendations based on that. Some of what he's done with InOversight is that he's made it possible for example, if you're running it on your Mac, for your Mac to pick up its roam events and store detailed information about the roam events. But one of the other things that's very handy about InOversight is that the developer has made it possible to take an iOS device, and this is really the impetus for the application originally, take an iOS device, untether it from a Mac, and walk around with the iOS device on the network and send this data back to the Mac for assessment. And so it's one of the primary ways that Wi-Fi consultants are now doing more detailed assessment of what's going on with iOS devices in the field. The application is a little bit opaque in terms of its UI. But it provides a rich amount of information that's not really easy to get any other way, and the application does reward kind of repeated use and experimentation. Provides significant amounts of information on network roaming, network connection stability on your client devices, and other factors that are often just kind of obscured in Apple's UI, both in iOS, iPadOS, and then also macOS devices. The end game here is to provide an overall assessment of the client connection, along with information about how InOversight arrived at these conclusions. Examples might include noting access points with low signal strength, noting when beacons were lost during transmissions, things like that. So moving on to network mapping and survey software, this is where the ecosystem for Wi-Fi analysis tools and Wi-Fi testing tools really starts to ramp up in terms of both complexity and also price. There's a whole ecosystem of suites of applications that exist to allow a user to create a walking survey of a facility's network. And this process and practice, what you'll do is hopefully you have an architectural diagram of your facility or multiple architectural diagrams of your facility, as the case may be. I've seen cases where Wi-Fi engineers will pull the fire evacuation plan off the wall and scan that and use that as a kind of a good enough. But as we say, garbage in, garbage out, the better the map, the better the assessment will be. What you're going to do is you're going to take that map and you're going to import that into your mapping survey application. And then you're going to walk around the facility with either a laptop or a tablet of some description, and possibly an external appliance, taking readings at regular intervals or sometimes even continually in order to gather information about that Wi-Fi network and that Wi-Fi environment. Once you walk the space and record data in enough locations, the application will create a reasonably complete picture and generate a variety of visualizations regarding the Wi-Fi environment in that space. The visualizations are going to allow interpretation of data in different contexts and for different reasons. Now, with respect to the market, I threw a few icons up there, through a few application titles. Kind of the big players historically have been Ekahau, has been the big one, kind of the flagship product flagship product suite. And then there's a smaller alternative company called Tamagraph that makes a product called Tamagraph Site Survey. In the last few years, a few other products have kind of risen up to do a little more. NetSpot Pro was the original Mac application for this and how I got my start. And then there's a new application called Hamina that we'll talk about in a bit. But using Ekahau for some of these visualization examples, it doesn't matter too much what you use to generate visualizations because they'll all generally tell you approximately the same thing, although a lot of the details will differ and a lot of the granularity in terms of what you can output will differ. In the visualization I have on screen, I estimated locations for access points on a facility that I'd never visited before. There's a couple of reasons you might want to do this during a survey. Business environments and specialty verticals often have specific requirements for concealing access points, either for aesthetic or security reasons. Sometimes we just don't want our employees to see the technology, and sometimes we're afraid that the kids in the gym are going to throw basketballs at the technology. Those two things happen. And so oftentimes, network administrators and installers will make a deliberate choice to conceal things. And if you're coming along after the fact and the documentation isn't great, well, here we are. The second case, of course, there's no documentation and you need to know where things are. There's also a third kind of corner case, which is you've realized that there's a problem with the network and you walk around and you find a piece of the old network still installed inside a closet somewhere. And so these are all reasons you might want to do a walking survey and locate this kind of equipment. In another example from the same facility, we can see Ekahau's report on the number of APs that are on overlapping channels for the facility. This in turn provides insight into how much co-channel interference to expect in a particular area to degrade performance. This visualization of the 2.4 gigahertz band in an office building shows that the number of APs broadcasting on the same 2.4 gigahertz channel are likely going to result in moderate to severe co-channel interference right in the center where the colors are warmer. That's where you see more overlap. Typically, this finding for an engineer would result in a recommendation to reduce the use of 2.4 gigahertz. One, because it's not all that performant. Two, is because it's extremely liable to this kind of co-channel interference. And a lot of what we would do is say, you know what, you've got 10 APs here, you're using mostly 5 gigahertz, turn 2.4 off on 7 of them. And you'll have sufficient basic 2.4 coverage, and you'll reduce the amount of co-channel interference you're going to get. The same data from the same survey generates a report showing signal levels across the facility, but some of the more advanced capabilities of the survey reporting may include the ability to visualize signal from the perspective of different types of devices. And so this visualization is a visualization for a presumed laptop with one type of Wi-Fi card, and then the following visualization will show you the expected performance or the expected coverage for a device such as a mobile device like your iPhone that typically is going to have a smaller antenna and a less powerful transmitter. And this is always one of the key things around Wi-Fi design. If you're not careful about what you're designing for and you design the wrong thing, you end up degrading performance for something that's really important. The term of art for this in the wireless vertical is design for the least capable, most important device, which in a lot of cases is probably going to be a C-levels iPhone. Finally, these network mapping tools contain a lot of different reporting options, and I've barely just scraped the surface on those. One of the key parts of a network mapping tool or a network survey tool is going to be the ability to generate a written report that outputs to a Microsoft Office file format, a PDF format containing visualizations, and in a lot of cases, pre-canned recommendations for what to do in certain contexts. For example, you have a lot of 2.4 gigahertz APs, turn off 7 of them. Or turn off the 2.4 gigahertz radio in 7 of them. These reports get very long. The report that I did for the office building that I just showed you was something on the range of 45 pages because I was displaying different visualizations for the 2 gigahertz band for both laptops and mobile devices. And that takes you to 4 or 6 visualizations per thing that you want to show. And one of the challenges with that is also, you generate a beautiful report, who's going to read that report? Is somebody going to read that report and understand that? So you want to be aware that that type of thing is an issue. And in some cases, the descriptions that come canned out of the applications are a little bit less well written than I would like. So, same set of icons, same set of vendors, same product suites. But flipping the script a little bit, we move from a process of what you can think of as a survey or an assessment of an existing network to a capability to plan for a new network. And again, each of these tool sets has some capability to do planning. And some of them are flagship tools and some of them are upstart tools aimed at different markets, and there are reasons for that. Different vendors have reached different levels of maturity, and that's going to result in a vastly different cost set and vastly different commitment in terms of learning. This is a planning visualization for a small warehouse network in Seattle. The visualization doesn't make it immediately apparent, but the design includes inputs for many characteristics of the network in the physical world, including the specific access point manufacturer and model, because those all have different transmission characteristics, different mounting heights, the expected transmission power output of those access points, orientation of antennas. It's not obvious from this particular visualization, but several of these include external directional antennas and are mounted to a 35-foot ceiling at a 45-degree down tilt angle. in order to provide coverage for specific purposes. In this particular case, the customer wanted to be provisioning handheld Android devices at a small set of desks in a corner. The original design had 6 or 8 access points pointing at those desks because the number that the customer originally wanted to provision was in the hundreds simultaneously, but the budget didn't support that, so we started with 2. Worked better than we expected at that point, but in some cases you still need more. But one of the key points of this, and one of the things that often gets lost in this discussion of, gosh, these applications are very expensive, is that a ruckus access point, a Meraki access point, and a mist access point might also have different characteristics for transmission and cover different areas. And if you're not very careful in terms of defining what you're using, you end up with problems in the result. And that's really where a lot of these costs come from. Additional things that you can build into a design in some cases, 25-foot warehouse racks assumed to be full of electronics to block signal, so on and so forth. And so kind of coming back to this market space, the capabilities of these products and the resulting costs are, to use one word, diverse. NetSpot Pro provides what I think of as a baseline introductory tool. Gives you a nice place to start with surveying. In version 3 that they released relatively recently, they added some planning capacity with a very limited number of access point makes and models, most of which are either in the consumer or the prosumer space. If you're interested in kind of playing around with surveying and playing around with planning, NetSpot Pro might be a good place to start, but if you're moving into this hard as a professional, or if you've got a large project to execute, there are some features that it just doesn't have. And so that's worth paying attention to. Tamograph is the one that I have the least amount of experience with because it's flown under kind of the radar of the market. I believe the company is located in Oceania, and so they have more market and more attention kind of in Australia and New Zealand than they do in the United States. Ekahau has really been kind of the product suite of choice and represents the gold standard for both survey and design work, and it has for years. However, in the last few years, the company was acquired. Some key people left the company, and if you're familiar with the kind of trend where a product is acquired and there's kind of a limited market space that's specialized, prices go up, possibly at a faster rate than features are added or bugs are quashed. And so that kind of lays the groundwork for competitors to kind of take root. All right, I need a show of hands. Who knows the concept of King Cotton? King Cotton? Cotton diplomacy? We're the US Confederacy, we've seceded from the United States, and we believe, and we're going to try to force Britain to recognize the legitimacy of our government because of the criticality of cotton to the world economy. That did not work out for the Confederacy. Britain's reply to that was, no, we outlawed slavery 100 years ago. We're going to start raising cotton in Egypt. Thank you very much. And this is kind of the thing that's happened in this market in the sense that with Ekahau having become such a flagship, such an expensive product, and having really kind of assumed that kind of position of we're the dominant power, you're going to kind of play along with us, a company called Hamina spun off, including a number of former Ekahau employees, and started generating their own product. There are some interesting things about Hamina, both as a survey package and as a network planning package. The most interesting thing about Hamina is that the network planning package is entirely web-based. And so you can subscribe, you can go online with a web browser, you can start designing and building networks. Another thing that makes Hamina attractive to a lot of people is that whereas Ekahau requires you to pay almost continually for maintenance, Hamina allows you to turn your license on and off in 6-month increments. One of the things that Ekahau did that made a lot of friends in the market was they went to a place where if you let your maintenance agreement expire for a year and you decided you wanted to, if you decided you wanted to renew it a year later, they asked you to pay for 2 years in order to maintain that. So diplomatically, making friends is not what they've done. And it is, and I cannot stress enough, it's a very good product. It does a lot of things very well. It is still the flagship gold standard, but some of this business market condition issue that they have created has led to the rise of Hamina as kind of a new upstart that's nipping at their heels, getting a lot of positive attention, and shifting away quite a number of the customers who frankly got mad. So, together with a lot of this specialty software, we also run into specialty hardware. Specialty software often requires, particularly for network scanning and network design, often requires functionality that imposes great performance strain on built-in Wi-Fi adapters, for example, that often requires functionality that's not built into a typical Wi-Fi network adapter. And so there's a lot of different pieces that you can play around with and that in some cases are required in order to have a complete package for either network surveying or network planning. These kinds of things include spectrum analyzers, which I'm going to get to. What I'm going to call survey peripherals, which is kind of a catch-all term for devices made by specialty software providers and hardware providers that combine a number of functions. There's a whole sort of category of handheld network testers. There's a few of those. And then there's kind of the catch-all category of the WLAN Pi community project. A spectrum analyzer lets you visualize raw radio frequency energy that makes up Wi-Fi transmissions and also other radio frequency transmissions that occur in the radio spectrum. This is useful especially in scenarios where you suspect you may have something non-Wi-Fi transmitting that is causing interference with your Wi-Fi. If you think of Wi-Fi data communications being analogous to speech in a conversation, you may find it useful to think of raw spectrum activity as any audible sound or noise at all that happens at the same time. So you got a jackhammer going next door while you're trying to have a conversation in a coffee shop, you have interference that is non-Wi-Fi interference. The whole trick of making both Wi-Fi and spoken conversation work is avoiding having kind of that random noise overwhelm the structured communication. Because if it does, the conversation becomes incomprehensible. The network communication will fail. You will have to retransmit. Sometimes things will just fall apart completely. So attaching a spectrum analyzer to something like a Mac allows you to show radio frequency information that is not Wi-Fi. This is a screenshot from Wi-Fi Explorer Pro from, I think, this room last night when things were quiet. This is what the 2.4 gigahertz band looks like when it's quiet, when most everybody's at dinner. 2.4 gigahertz is still a little bit messy. If you look at those bottom spectral masks showing the individual access points, you can see a whole bunch of access points that are on each channel. Those are going to generate co-channel interference. Those are probably going to generate retransmissions in some cases, and that's going to generate increased traffic. So even a quiet 2.4 gigahertz network in a corporate environment or a dense environment can be fairly busy. Looking at it this morning, you can see a greater density of radio frequency transmissions. This is visualized by the increased color at the top, and there's some masking at the bottom that shows increased activity. Comparatively, you can look at the 5 gigahertz traffic in the same room. Again, this is during the quiet time after dinner last night, and during the beginning of sessions this morning. And so you can see that there's a lot going on even if you can't necessarily tell what it is. One of the things that shows up on spectrum analysis, again, is all of those things that generate RF energy that are not Wi-Fi. Your microwave ovens, your security cameras. I'm semi-famous for carrying around a baby monitor kit that will dump all over the Wi-Fi and render the network kind of useless. I didn't get to bring it with me this year. And then you can also see things like non-Wi-Fi signal generation. You can see, here's an example of non-Wi-Fi signal generation, allowing an administrator or an engineer to identify potential sources of interference. So this is what spectrum analysis is useful for. I'm going to take a step back for just a second because one of the things I like about Wi-Fi Explorer Pro is that the author has integrated a number of different spectrum analyzers that you can just plug straight into your USB and generate information about what's going on. Vendors include companies like RF Explorer, that's the unit on the left. They have a few units that cost a few $100s. The unit on the bottom right is from a company called MetaGeek that no longer exists. It was acquired by Auvik, but it's a great product. It's a Wi-Spy DBX. And then the item in the center is an Osmium spectrum analyzer that is also good for 6 gigahertz. And this kind of raises one of the issues around Wi-Fi hardware. Every time the standard changes, the equipment changes. And this is one of the reasons why sometimes I'm not all that eager to do things. This is a digression. I'm not all that eager to go out and buy Wi-Fi 7 access points for my network at home because Apple doesn't make anything that has Wi-Fi 7 in it. So why spend the money at that point? If you're an institution, there's an argument to be made that your replacement cycle is going to be every 5 years, every 7 years, every 10 years. Go buy the best, most expensive thing you can get because it's going to have to last a really long time. But it's not always the case. We're still waiting for Apple to introduce something with a Wi-Fi 7 card in it. They just finished converting the product line to Wi-Fi 6E, adding 6 gigahertz. It's been something like 6 months. Hasn't been that long. So then, stepping up to the next set of capabilities, and we start to talk about survey peripherals, these tend to be proprietary devices that are manufactured or contracted to be manufactured to particular software vendors. So Ekahau manufactures what they call their Sidekick, and their Sidekick includes several Wi-Fi network interfaces that they can use to do packet captures and scanning, along with its own spectrum analyzer. This is a multi-$1,000 piece of equipment to carry around. They provide a strap, you hang it over your shoulder, you plug it into an iPad or an Android tablet, and you run a special application, walk around and do your surveys as I described earlier. Hamina has contracted with the company Osmium to create a device called the Nomad that's very similar. Multiple network interfaces contained inside the box along with a spectrum analyzer. License Hamina's survey application and you can do these kind of surveys. Further, Hamina is also supporting the WLAN Pi equipment for survey because it knows that specialty equipment is very expensive and there are a lot of people out there with WLAN Pis already. Moving on to handheld testers, there's really one of these that's very prominent. It's the NetAlly AirCheck G3. It'll do a lot of the same network testing that things like Wi-Fi Explorer will do. It will do iPerf tests. It has a mapping module that you can install in a handheld. Great for troubleshooting, fairly expensive piece of equipment, also not as integrated in the macOS ecosystem. And then there's the WLAN Pi itself, which is a series of Raspberry Pis with a software stack developed by a number of members of the Wi-Fi professionals community, tailored for testing. It can be used as a remote sensor. It can be used as a survey tool. It's a little bit annoying to maintain if you're just kind of like, I'm a Mac person, I just want something to plug in, because that's the way I am with respect to these kind of tools. I just want it to do a thing. But there's also a lot of very advanced software being deployed to it constantly, so that if you want to do new types of testing, this is a great thing to pay attention to. So let's take some risks here. And let me see. I don't know if I can make this happen or not. All right, so this is the Wi-Fi Explorer Pro capture from the 200 side of the building from yesterday when notes were going up in the Slack regarding complaints about the performance. And I wasn't lucky enough to be on that side of the building, so I had to beg a friend and colleague to send me their file so that I could load it into Wi-Fi Explorer and show it to you. But what this shows on the right-hand side in the bottom quadrant is that in the 5 gigahertz band, there is a series of Aruba access points that are configured with 2 particular characteristics. One characteristic is that they're all on the same channel, or rather there's a pile on one set of channels and a pile on another set of channels. So they're generating co-channel interference, meaning that, okay, co-channel interference, the idea that Wi-Fi is essentially a cooperative technology where everyone has to take their turn. And the more people there are on a channel, or the more devices and transmitters there are in a channel that can hear one another, the longer they have to wait to take their turn and the shorter the turns are. This degrades performance. And so whenever you see a concentration of access points in close proximity that are all on the same channel, you can look at that network and say, I see problems coming. And this is what happened at the other end of the building. It's a bit of a mystery to me because this is the same equipment that's been installed in the Penn Stater for years. This equipment has not always been configured this way. This equipment was previously configured appropriately so that different access points were resident on different channels. The best I can gather at this point is this is the type of thing that happens when a firmware update gets rolled out, resets your defaults. It's done when there's not a lot of people around, and as a consequence, nobody's paying attention to the changes that result from that. So all of a sudden, you're dealing with this industry that believes in marketing speed. That is, the AP manufacturers, the network equipment manufacturers. Defaults, we come out of the box with 80 megahertz channels, even though no Wi-Fi administrator would ever recommend that in an enterprise network. And so we reset to defaults. We reset to 80 megahertz channels, and we start to auto-detect which channel we should be on, and we do it badly. Again, speculation on my part. I've seen it happen with enough manufacturers of enough equipment because in general, my attitude and belief is this is the kind of thing that the network vendors really do sort of push towards. They really do push towards this idea of this is going to be as fast as possible, even though that might not be the thing you really want to do. So, I don't know. Okay, so here's this morning. Overnight, the network team for the Penn Stater, I'm not exactly sure who they are, they went out and they grabbed a bunch of additional equipment. And they installed it properly. So you can tell there's a difference in equipment because there's really 2 brands here. There's HPE Aruba, which was sort of the incumbent equipment that's been here for a few years, and then equipment from a company called Xeris started to show up. And the Xeris equipment is configured the way that you would expect for an enterprise or a high-density network. Narrower channels, lots of spread among the channels. And as far as I know, what they did was they provided that new Xeris equipment and they generated new SSID for that side of the building for people to connect to so that people would no longer be connecting to the problematic Aruba equipment. This is a partial fix because if you look closely, the oddly configured Aruba equipment is still sitting at the bottom of the 5 gigahertz spectrum and the top of the 5 gigahertz spectrum. It didn't get torn down. It didn't get its configuration modified. As best as I can figure, And again, I am frankly overstepping myself a little bit in terms of making this assertion, but the hotel did change hands in the last couple of years. As best as I can figure, there's a new team that either doesn't quite have their head around the HPE Aruba configuration, or doesn't have time to log in, or doesn't have the access privileges to log in and make those configurations. So what they're doing is they're layering a new network on top of the existing network. This isn't a perfect solution. And this is the kind of thing that Wi-Fi Explorer can show you. So let me see if I can bring Yep, and now I've apparently lost my keynote back, but I'm just going to talk through the rest of this because there's very little visual here, because we've kind of gone through the tool set, we've gone through Apple's tools, we've gone through the third-party software, we've talked about third-party hardware, and the thing that I want to land on here is the world of technology has a lot of magical thinking in it. If we just go buy this new HRIS system for our organization, it'll solve all of our institutional problems with data management. If we just implement SAP, we'll solve all of our problems with manufacturing management. And by implementing SAP, what often is meant is we paid for the licensing and we handed the licensing to somebody in the IT department to figure out. We don't actually have a project for it yet. Had this experience? Lived this? Yeah, okay. So one of the things that I don't like about kind of the whiz-bang world of tools and technology and vendors and things like that is all of these tools are very powerful. They're all relatively useless without relevant knowledge and experience. And that's one of the things that makes Wi-Fi hard. Tools are minimally useful without understanding. Some actually contribute to misunderstanding. As an example, okay, let me get one more show of hands. Who's run a speed test on a Wi-Fi network? Ookla speed test. Have you run Ookla speed test? Do you know how many clients were on that Wi-Fi network transmitting at the time you ran the speed test? If the answer is more than one, then you have no guarantee of a speed test result, because Wi-Fi is a shared medium. You know, if you have 4 busy clients, the network performance in aggregate may remain similar, but the individual client performance may be quartered. The more clients you have, the worse the performance gets. And so there can be a built-in assumption around tools that a tool is telling you the truth, and a tool is not always telling you the truth. Or a tool, more appropriate, it may be more appropriate to say it's telling you its version of the truth, which is not complete. And this is a problem for understanding. So as far as increasing your ability to use these tools, I mean, I've gotten in trouble before for saying things like, you know what, just go hire a Wi-Fi professional, go hire an engineer. And that's sometimes a fair thing to say when an organization doesn't necessarily feel like they have the resources to grow their own expertise. But if you're going to do something like invest in a lot of these tool sets, there's also the need to invest in the expertise. And some of that goes beyond, really most of it goes beyond understanding the tools themselves, because you can do a lot with the tools, but in order to really optimize the use of those tools, you need to optimize your understanding of the technology in the first place. If you don't understand how Wi-Fi works, you want to go out and understand how Wi-Fi works before you start or while you start to try to apply tools to it. There's nothing in Wi-Fi Explorer Pro that says, oh, hey, look at all of those access points on the same channel. You have to know that. You have to have experienced it and lived it. And there's a number of ways to really kind of to deal with that. Things including The CWNP organization, Certified Wireless Network Professionals, provides a series of vendor-neutral engineering certifications that often draw from people from across the industry and provide a baseline set of knowledge for how Wi-Fi is supposed to work. I'm often not been necessarily the biggest fan of certifications as kind of a career building move, but I do believe that the CWNP stuff provides the baseline from both the introductory administration of wireless networks to extremely sophisticated analysis practices, understanding the contents of the various packets and their elements. That CWNP stuff can be worth pursuing if you really want to get into Wi-Fi and understand Wi-Fi. Vendor training and certification can also be very good. By and large, most of the major vendors follow most of the standard practices. 75% of the standard practices, 50% of the, or a common set of standard practices in the 802.11 certification. And so, in general, vendor certifications from companies like Aruba, Cisco, Mist, Cisco Meraki, those can all be very good with the understanding that you're also going to get a lot of that vendor's own special sauce and special attitude to go with it. And when you go look at another vendor, that other vendor is going to make a slightly different recommendation about how to do things, or they're going to have a proprietary thing that has a different name and you're going to have to figure that out. Still a good way to go though. As far as Apple documentation, Apple's deployment guide has a lot of good information about how Apple works with Wi-Fi. A lot of good spec information. That being said, Apple doesn't believe in the past. Apple believes in the now and the future that they haven't told you about, which means that Apple's deployment documentation no longer includes any technical specs for Intel equipment. That was, the Intel dropped out of the documentation in the last revision. It's all Apple Silicon all the time now. And if you want to learn more about what Apple Intel equipment was doing, how many people still have significant Intel? Can I get a show of hands? Yeah. I mean, it's not awful. That information is pretty findable and pretty discoverable, but you have to be aware that Apple's sort of position is we move you forward and we don't hold you back, and if you don't move forward, well, And then finally what I would say is two more things about learning and engaging around Wi-Fi. One is that the Wi-Fi community is in some ways very similar to the Apple community, the community of Mac system administrators. In general, Wi-Fi administrators, Wi-Fi specialists are often one of two people on their staff. They are often getting most of their knowledge from lateral relationships with other people they've met in other organizations that do the same thing. The Wi-Fi community has a very strong conference circuit, very strong certification training circuit. There are a couple of very good conferences every year where you can go and learn. By and large, it's a pretty open community, even though that it's also kind of a networking community. So there's a little bit of the every vertical has its own set of attitudes. Networking has one, and you do have to be kind of aware of that. But it is a very good, very strong community. They have their own Slack, Wi-Fi Pros Slack, that you can get an invitation into. And then we also have a pretty strong community in the Mac Admin Slack that I'm a part of. And then finally, what you're going to do, if you really want to get into this, you really want to learn to use these tools and apply them effectively, you're going to build, troubleshoot, and tear down your own networks. The first one will be wrong on some level. That's okay, because Wi-Fi in general is a technology that's built with a certain amount of resiliency in it. So even a network that's built wrong will usually work at a level of 50%, 60%, 70% until you do something like get a conference center that hasn't had anybody in it for 3 months, and then suddenly 200 people show up and try to use 4 access points. So you're always going to be making networks, you're always going to be breaking networks. And that's just kind of the way it is. So I encourage you to kind of look at these different methodologies for sort of increasing your own knowledge, because without increasing that knowledge and sort of developing that experience, a lot of these tools will be useful, but they may not do you all that much good. And you really want to combine those two things. You want to combine the tools, you want to combine the knowledge and experience. And you know, there's a famous Terry Pratchett quote from one of the Discworld books. It's still magic even if you know how it's done. And that's really, that to me is the essence of Wi-Fi. And that's all. Questions, comments, invective, and abuse on where is the catch box? Way in the back. All right, I'm gonna start midway. Let's protect our bottles because my circle of error is probably 50 feet at this distance.
So, hello, testing.
Yep.
Is that on? Okay.
I gotcha.
So I have a question about what if I wanted to collect this data across my fleet at like a regular interval and then ship it somewhere so I can trend like Wi-Fi health and access point health like over time? Do you have any?
This is a fun conversation because of what just happened with the airport toolset and Apple's deprecation of the airport toolset. One of the things that I discovered, I've been railing against the use of airport for a number of years because people were using it for a number of things that it wasn't supported for doing. People were using it to try to adjust roaming and change the way Macs roamed on a network, and I've never felt so shouted at in an Apple Care ticket as when I worked with a colleague to send a proposal to do that up the chain and said, is this going to work? And the answer was no. But it was, no, don't do that. So, and what that meant was that I kind of missed the idea that people were using airports to gather that information. And this is troublesome and problematic right now because basically everything that's compiled on a Mac, as far as I know, needs location services access, and Apple treats a lot of this Wi-Fi information as sensitive private information that requires location services access. So I don't know that I have an answer. I've seen a couple of folks in a couple of kind of the quasi-developer channels on the Mac admin Slack talk about this. One of them shifted to using the WDUtil tool and set up a separate sudoers file for his application to define the privileges that WDUtil would have to grab that information. And so his particular tool, this is a tool called PanSift. It's a lightweight network monitoring tool. His particular tool now installs that extra sudoers modification in order to allow that without having to enter an administrator password to gather the information, without having to escalate privileges. I saw another conversation today, because I was following up on this question, that in some cases people have just kind of given up in terms of they deploy the tool, but because, as far as I know, location services has to be turned on by the user for a tool manually, they're not trying to mass deploy the location services configuration. They're waiting until the user has a problem where data needs to be gathered, and they're using help desk to walk the users through that.
Gotcha.
I think that depending on the type of information you're trying to gather, if I wanted to yell and submit feedback, one of the things I might be doing is submitting feedback asking Apple for some kind of exception to this for a DEP or an Apple device enrollment enrolled in MDM managed system, because we know those are institutionally owned and they have different rules. But that's going to require escalating that feedback to Apple and having that conversation. And we all know what what happens when you escalate feedback to Apple. Sometimes it works, sometimes it doesn't. You have to beat that drum. You have to gather forces. You have to marshal, colleagues who are also having these problems. Sorry, I don't have a better answer for you right now. Next.
All right, I actually have a little bit on that last one. You can actually trap where you're able to get a unified logging and send that to whatever log tool you're already using. And then presumably your Wi-Fi controller can do the same and time code it. That's not everything, but it's better than nothing. I know we use Aruba Central and you can look at those correlated, and it's not perfect, but it's usually enough.
One thing to be careful of in that particular context is, given the rise of remote workforce, a lot of the time your folks are not on a network being managed by your central WLAN controller, which isn't to say that you shouldn't be doing that. It's not to say you shouldn't be gathering metrics from your controller, because that's something that I see people not doing enough when they're attempting to troubleshoot. A lot of that, to me, comes down to a cultural issue where the client endpoint team is bifurcated or isolated from the network management team, and they don't necessarily like to trust and talk to one another. We should be doing that more because there's a wealth of information in those systems.
I do have an opportunity leading question here a little bit. Run into several production issues over the years, especially running slightly older hardware, with Apple essentially disavowing the Intel side of things, but still patching the OS for many Intel platforms. Do you have any advice or recommendation in terms of how to format your feedback or get feedback to Apple when they say forget to patch a chipset driver that it changes Wi-Fi functionality for a
I
particular
probably
platform?
don't personally submit enough feedback to do that, but I could probably connect you with a couple of folks who would be interested in having that conversation about how to do that.
I know that's been a long road for us when we've run into things,
Yeah.
finger pointing between Aruba and Apple in this case, with respect to roaming on Intel.
Yeah. Yeah, and we've seen other issues with Intel as well. Apple did not implement advanced roaming protocols on Intel. They left it only on Apple Silicon devices, or they introduced it only on Apple Silicon devices. The writing's been on the wall for a while, and this, to a certain extent, is a consequence of Apple's approach. But I think that there's a place for submitting that feedback as long as they're still supporting that operating system on that hardware platform. I think it's a conversation worth having. If we can connect after the session, and I can tell you who we should talk to.
Absolutely. Who's next?
Just a curious question. So we have two access points at the two different locations, and if a user carries a mobile device moving from one location to another, at which point the Wi-Fi device switches the access point?
I have a whole talk on that topic from last year that I can point you at. I've done two talks on Wi-Fi roaming. I did a talk a few years ago called Roam If You Want To, which was kind of I'm still feeling my way through this topic and I'm not quite sure I understand it. And then last year I redeveloped the talk under the title Roam Revisited. And you can find the whole long discussion and the kind of overwrought technical details in that particular talk, because that's its own 75-minute talk, half-day workshop type of thing.
Okay, so there's no...
Because Apple has significant documentation for that, but there's also a lot of understanding of how Wi-Fi works and how Wi-Fi signal strength works that goes along with understanding how Apple interacts with that. They do document their rules for roaming in their deployment guide, so some of that information is there. But as with all technical documentation, it doesn't always hit the sharp corners and take you through the odd scenarios that might adversely affect your scenario. But I don't like to recommend that people watch my own talks because I always look back on them and I'm kind of like, oh, I could have done that better. But there's a lot of good information in that talk from last year, and I would recommend starting there.
Okay, thank you. All right, I got you.
Anyone else? Well, thank you for your patience with my flusteredness, my apparent ability to break Keynote, and my inability to read my own slides once Keynote was broken. I appreciate it.